Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Maximal score after applying k operations, Leetcode 2530. In this problem, we are given 0 index array nums and an integer k. We have a starting score of 0. In one operation, we can choose an index I such that I is within bound of nums array and increase the score by nums I and replace that number nums I with ceiling of number nums I by 3. And in the end, we return the maximum possible score we can attain after applying exactly k operations. The ceiling function returns the least integer greater than or equal to given value. For example, ceiling of 3.33 is 4 and ceiling of 4 is also 4. So it can be either equal to or 1 greater than the integer value of the given number. Then in example 1, for given array nums with k equal to 5, we return 50 because after applying k operation, the final score will be equal to 5 times 10. So this is an easy example, but example 2 is better. In example 2, k is equal to 3 and number of elements is equal to 5 in the array. Now for the maximum score, which element should we pick up? We should pick up the largest element, right? So we pick up 10 and 10 by 3 is 3.33 and the ceiling value for it will be equal to 4. So we replace 10 with 4, but our score now becomes 10. Then our array becomes 14333 and again which is the largest element? It is 4. So we again replace 4 with 4 by 3. That is the ceiling value of 1.3 which is equal to 2. So now our score becomes 14 and again we pick up the largest element. So we can pick up any of the 3. So suppose we picked up this 3. Now we replace 3 by 1 and our score now becomes 17. And now we have done k equal to 3 operations. So we are done. So 17 is our answer. So in terms of solution, we need to pick up the largest or maximum available element in the array and we have to do it repeatedly. One method can be sorting, but sorting the array and picking up the largest element again and again may not be very efficient. Then which data structure can actually help us find the maximum element in a very efficient way? And the answer is max heap because getting the maximum element just takes O of 1 time. Of course, adding and removing an element to the max heap will take log of n time, which is still faster than sorting the array, which will take O of n log n time. So then our process will look something like this. We first create max heap from n elements in the nums array. Suppose we take nums array from example 2 and then we perform exactly k operations. In example 2, k is equal to 3. Now we perform first operation. We can see that the maximum element in the heap is 10. Now the maximum element in the max heap is 10. So we remove it. That takes log of n time. And then we replace it with ceiling of 10 by 3, that is 4. So we add this element to the heap. That will again take O of log n time. So now our score becomes 10. Now we perform second operation and 4 is the maximum element in the heap. So we pop it out and put back 2. And now our score becomes 14. Now this is our third or last operation. And this time we again pick up the maximum element. Suppose we pick up this 3 and replace it with 1. So that's how we will get score equal to 17. And the time complexity to build the heap will be O of n, where n is the number of elements. And in Java, we use the priority queue implementation. And if we offer elements to the heap one by one, that will take O of n log n time. But if we use addAll method to add the elements, that will take O of n time. But the problem with that method is that we have to convert this primitive integer array to list of object integers that will again take O of n time. And then we are actually applying k operations and removing and adding an element takes log of n time. So because of this, time complexity will be k log n. And in terms of space complexity, it will be O of n because we are storing n elements in the max heap. So now let's jump into the code part. First, let's create a max heap. We can use the priority queue implementation in Java to do that. And because we are creating a max heap, we have to pass a custom comparator. So we can pass in two values a and b. And because we want it in reverse order, we will just want b minus a here. And now we will add all the elements to the max heap from the input nums array. And we can use priority queue.offer to do that. And now we can start performing k operations. So initially our score will be equal to 0. Now we will perform k operations. So we will pull out the largest element from the heap, add it to the score, get the new value for it, which will be ceiling of number by 3. So we have to convert it to double. Otherwise, we will lose the floating value or decimal value due to integer division, and offer this new element to our max heap. So that's it. Now we will just return the score. Let's run this code. I'm adding nums array instead of number itself to the max heap. So let's submit this code. Cool. So because of this add method, the time complexity is O of n log n. But if we want to improve it to O of n, we have to pay a price in terms of code complexity. First, we have to convert this primitive nums array to integer object list in Java. And now we can add this whole list to max heap, which will result in time complexity of O of n instead of O of n log n. Now let's run this code. There is no n defined. I should be passing nums.length here. Let's run the code again. Cool, let's submit it again. So you see the code is now slower. That's how the test cases are set up. But asymptotically, this code is faster. But again, it's up to you. I prefer the previous solution because of the simplicity. I hope this video was useful to you. If it was, please like, share and subscribe. If you have any questions or comments, please write them in the comment box. Thanks for watching. See you next time.